Passwd is a tool on most Unix and Unix-like operating systems used to change a user's password. The password entered by the user is run through a key derivation function to create a hashed version of the new password, which is saved. Only the hashed version is stored. The entered password is not saved for security reasons. When the user logs on, the password entered by the user during the logon process is run through the same key derivation function, and the resulting hashed version is compared with the saved version. If the hashes are identical, the entered password are considered to be identical, and so the user is authenticated. In theory, it is possible to occur that two different passwords produce the same hash. However, cryptographic hash functions are designed in such way that finding any password that produces the given hash is very difficult and practically unfeasible, so if the produced hash matches the stored one, the user can be authenticated. The passwd command may be used to change passwords for local accounts, and on most systems, can also be used to change passwords managed in a distributed authentication mechanism such as NIS, Kerberos, or LDAP. Password file. The /etc/passwd file is a text-based database of information about users that may log into the system or other operating system user identities that own running processes. In many operating systems, this file is just one of many possible backends for the more general passwd name service. The file's name originates from one of its initial functions, as it contained the data used to verify passwords of user accounts. However, on modern Unix systems, the security-sensitive password information is instead often stored in a different file using shadow passwords or other database implementations. The /etc/passwd file typically has file system permissions that allow it to be readable by all users of the system, world readable, although it may only be modified by the superuser or by using a few special purpose privileged commands. The /etc/passwd file is a text file with one record per line, each describing a user account. Each record consists of 7 fields separated by colons. The ordering of the records within the file is generally unimportant. An example record may be Smith, X1001:1000 Joe Smith, room 1007, 234, 555-8910, 234, 555-0044, email, /home/smith/bin/s. The fields, in order from left to right, are: the first field is the username, that is the string a user would type in when logging into the operating system, the log name. Each record in the file must have a unique username field. The second field stores information used to validate a user's password. However, in most modern users, this field is usually set to X or some other indicator, with the actual password information being stored in a separate shadow password file. Setting this field to an asterisk is the typical way to deactivate an account to prevent it being used. The third field is the user identifier, the number that the operating system uses for internal purposes. It does not have to be unique. The fourth field is the group identifier. This number identifies the primary group of the user. All files that are created by this user may initially be accessible to this group. The fifth field, called the Jekyll field, is commentary that describes the person or account. Typically, this is a set of comma-separated values including the user's full name and contact details. The sixth field is the path to the user's home directory. The seventh field is the program that is started every time the user logs into the system. For an interactive user, this is usually one of the system's command line interpreters, shells. Shadow file. /etc/shadow is used to increase the security level of passwords by restricting all but highly privileged users' access to hashed password data. Typically, that data is kept in files owned by and accessible only by the superuser. Systems administrators can reduce the likelihood of brute force attacks by making the list of hashed passwords unreadable by unprivileged users. The obvious way to do this is to make the password database itself readable only by the root user. However, this would restrict access to other data in the files such as username to userid mappings, which would break many existing utilities and provisions. One solution is a shadow password file, to hold the password hashes separate from the other data in the world-readable password file. For local files, this is usually /etc/shadow on Linux and Unix systems, or /etc/master.passwd on BSD systems. Each is readable only by root. Root access to the data is considered acceptable, since on systems with the traditional all-powerful root security model, the root user would be able to obtain the information in other ways in any case. Virtually all recent Unix-like operating systems use shadowed passwords. The shadow password file does not entirely solve the problem of attacker access to hashed passwords, as some network authentication schemes operate by transmitting the hashed password over the network, sometimes in clear text, for instance, telnet, making it vulnerable to interception. Copies of system data, such as system backups written to tape or optical media, can also become a means for illicitly obtaining hashed passwords. In addition, the functions used by legitimate password checking programs need to be written in such a way that malicious programs cannot make large numbers of authentication checks at high rates of speed. On a system without shadowed passwords, typically older Unix systems dating from before 1990 or so, the password file holds the following user information for each user account. Username. Sold combined with the current hash of the user's password, usually produced from a cryptographic hash function. Password expiration information. User ID, UID. Default group ID, JIT. Full name. Home directory path. Login shell. The password file is readable by all users, so that name service switch can work, for instance, to ensure that usernames are shown when the user lists the other folder, but only the root user can write to it. This means that an attacker with unprivileged access to the system can obtain the hashed form of every user's password. Those values can be used to mount a brute force attack offline, testing possible passwords against the hashed passwords relatively quickly without alerting system security arrangements designed to detect an abnormal number of failed login attempts. With a shadowed password scheme in use, the /etc/password file typically shows a character such as asterisk or X in the password field for each user instead of the hashed password, and /etc/shadow usually contains the following user information. Shadow usually contains the following